Okay, so carbon's a positive 4. Turn to the next page. We're going to practice this. Okay, I believe you have 8 practice problems on the next page. Okay, so this is where you're referring to, this and your periodic table. Okay, so do you want to go over them together? It's kind of a lot. Okay, so number 1, you tell me what just happened. There you go. All right, number 1, what is the usual oxidation number on hydrogen? +1. So we're going to put a +1 on hydrogen. What's the usual oxidation number on oxygen? -2. Okay, so do those oxidation numbers add up to 0? Yes. I have 2 hydrogens at a +1. This is a +2 and a -2. Those add up to 0. Does that make sense? Yeah. Okay, let's go to number 2. Cesium. Cesium is an alkali metal. What is the usual oxidation number for an alkali metal? +1. Okay. And the reason I did that is because this is a metal with O2, so we should be suspicious that this is peroxide. So what would the charge or the oxidation number be on oxygen here? It would have to be -1 because that's the only way to get them to add up to 0. So yeah, that is peroxide. Okay. For number 3, assign oxygen, because we don't know what carbon is. So assign oxygen its usual oxidation number, which is what? -2. Okay, so then we're going to figure out carbon using basic algebra. So carbon plus, how many oxygens do I have? 3. What is the oxidation number on oxygen? -2. What is the charge on the polyatomic ion? So this right here, right? Okay, so this all adds up to that charge. So C minus 6 is -2. What is C? 4. Does that make sense? Yeah. Okay. Number 4. Na is an alkali metal. What are the usual oxidation numbers for alkali metals? +1. Okay. Oxygen is usually what? -2. So we need to calculate chromium. How many sodiums do I have? 2. So it's going to be 2 times a +1 plus, how many chromiums do we have here? 2. So it's going to be 2 times Cr plus, how many oxygens are here? 7. So it's 7 times -2, and this adds up to 0 because this is a neutral compound. Okay, what's 2 minus 14? -12. Throw the 12 on the other side. Divide by 2. Chromium is +6. Number 5. Barium is an alkaline earth metal. What is the usual oxidation number of those? +2. Hydrogen has to be what in this case? -1, because this is a metal hydride. It's a metal with hydrogen, so hydrogen has to be a -1. That allows us to add up to 0. Okay? For number 6, you know that hydrogen is what? +1, so that means you have to calculate nitrogen. So nitrogen plus how many hydrogens? 4 times a +1 equals what? 1, because that's the charge on this polyatomic ion. So N plus 4 is 1, subtract 4, N is -3. What's the oxidation number of sulfur in number 7? Careful here. There's no negative or positive. What was the first rule?
0.
Yeah, this is elemental form, pure form. Okay, so it's just 0. For number 8, we know that aluminum has an assigned charge. What is it? Plus 3. That means it would be its usual oxidation number. Okay. We know that oxygen is -2. So we can calculate sulfur from here. How many aluminums are there? 2. 2 times 3 plus how many sulfurs are in here? 3. So 3 sulfurs plus how many oxygens? Multiply that. 12 times -2 adds up to what? Is that neutral? 0, because it's neutral. So 6 plus 3s minus 24 is 0. What's 6 minus 24? 18. -18. Put the 18 on the other side. You're going to get 3s equals 18. Divide by 3. You're going to get s is what? Positive 6. Okay. Can I go on? Okay, let's go to the definitions for oxidation and reduction underneath here. Okay, so oxidation and reduction has to do with gaining or losing electrons and whether your oxidation number is increasing or decreasing. So let's come here. If you have a decrease in oxidation number, that means you have got a reduction. If you have an increase in oxidation number, that means you have oxidation. So oxidation is actually a loss of electrons. Reduction is a gain of electrons. And the way that we determine this is by using the oxidation numbers. Okay, so let's take a look at the reaction that's towards the bottom of this page. Okay, let's come down here. Let's look here. On the left-hand side, this is elemental iron. It has an oxidation number of 0. This is a monoatomic ion. It has a charge of +2. That is its oxidation number. This is also a monoatomic ion, so its oxidation number is +2. This copper over here is elemental copper, so it's 0. Read this from left to right. The iron goes from a 0 to a +2. So that means that this is an increase in oxidation number. Okay? Anytime the oxidation number increases, you are losing electrons. So this is a loss of electrons. And when you lose electrons, you're being oxidized. So that means this is oxidized. Okay? So loss of electrons is oxidized. When I look at the copper, I'm going from a +2 to a 0. So that means my oxidation number is decreasing. So when your oxidation number goes down, that means this is a gain of electrons because I'm gaining negative charge. That means this is reduced. You will only label reactants as being oxidized or reduced. You will never have that label on the product side, okay? And that's because redox reactions are an exchange of electrons between reactants, okay? Okay, so what's happening here is, if I do this in a different color, the electrons are actually moving from here to here. And since the oxidation number changed from a 0 to a +2, that means 2 electrons are moving from iron to copper +2. If I had a coefficient or a subscript present, I'd have to consider that when I determine how many electrons moved. Okay? Okay, let's take a look at the next page. On the next page, there's a mnemonic that you can remember to help you with what is oxidation and what is reduction, okay? So here we covered that loss of electrons is oxidation. So if you abbreviate that as LEO, and then gain of electrons is reduction, that would be GR. So Leo the lion goes GR is a really good way to help you remember loss of electrons is oxidation and gain of electrons is reduction, okay? Now, let's look at the quick check. Let's come down here. Iron is here, and they gave us the corresponding oxidation numbers. So as you read it from left to right, the oxidation number is decreasing, okay? So if the oxidation number decreases, that means this is a gain of electrons. So that means that this substance right here is reduced. And when it's an ionic compound, you need to tell me what ion it is. So in this case, this would be Fe+3 that is reduced. Because if you just said Fe is reduced, you'd be talking about this product over here, which is incorrect. Okay? Now, are electrons gained or lost by each iron ion? Gained. Okay. How many? I went from a +3 to 0. 3, is there a subscript or a coefficient on the iron? 6. So by each iron ion, it is gaining 3, right? For each one of them, because there's 2 of them, okay? All right, when we look at the other, so here we're going from this aluminum to this aluminum, and here are the oxidation numbers. As I go from a 0 to a +3, this is a loss of electrons, right? Because this is being oxidized. So electrons are being lost by each aluminum atom. How many? 3, right? Because I went from 0 to +3. So we're going to put a 3 here. That's by each atom. There's a coefficient on the aluminum, though, right? Of 2. So how many electrons are transferred total? 6. Did anything happen to oxygen? No. Oxygen is staying at a -2. So we don't care about the oxygen. Okay. All right, let's come down here. Since we now know how to label things as being oxidized or reduced, whatever is reduced, it acts as an oxidizing agent. That means whatever is reduced will oxidize the other reactant. Okay? And then whatever is oxidized, it acts as a reducing agent, which means whatever is oxidized will reduce the other reactant. And let me show you how to label that. Go ahead and turn to the next page, which is the last page. We're going over here to the practice problems, okay? And I'm going to need to stop this.